This is math as a core reasoning skill, taught by Krista and I. So a little bit of background on mathematics. One of the things that I like to emphasize is that the doing of math is not the point, right? All the that's some of the point, but that's not the main thing. So, what? You're laughing at me.
It's not the main thing. You're cute.
Um,
Sorry. I like you. I think that's funny and endearing.
Yeah, so math is kind of a core reasoning skill. And I tell people that when you learn something about math, if I learn something about biology, I just know something new about biology. If I learn something about physics, I just know something about physics. But if I learn something new about math, I know something new about everything. And so that's one of the amazing things about math. And skills in math also go to every other thing. And so that's why it's so important. Traditionally, math focuses on arithmetic, formulas, equations, and tricks to do those things. And that's not bad, but I think it's limiting into what you can actually gain from mathematics. So what I view math as being about reasoning skills, and that every time you learn math, you're learning a way to do reasoning very rigorously. It's about defining problems rigorously. That's one of the things that's hardest is to convert kind of a fuzzy sounding problem into a very rigorous problem. And that's how every advance anywhere has been made, is by someone taking something that sounded fuzzy and converting it into something very concrete. And so all the word problems are practice at that. Practice at saying, okay, I hear this, what does this mean?
And this is the part of the information they just gave me that I need to solve the problem, and that other part is not necessary. Because they love to throw all that extra stuff in there, and you don't always care.
The thing that I find most interesting about math is that with math, if you define a problem well enough, you can actually convert your questions into answers. It's like a conversion process. Because if you think about it, how do we solve a problem? If you've got an algebra problem, you have x, 3x plus 5 equals something. We have a question, but what you're actually going to do with that is you're going to convert the question into the answer. And I just find that utterly amazing, that you can take a question, and if it's defined well enough, then the question actually converts into its own answer. And that's an amazing thing about math, and it applies everywhere else. So we kind of put together what we think are kind of the levels of math. All right, and these do not correspond with any particular textbook levels, but just kind of start out with number sense. That's the first thing to teach, and correspondence.
We have generals. We have specific slides on
each
of these, right?
Yes.
Okay.
So, and then you can move into arithmetic, where you're actually doing the numbers more directly. With number sense, you're just kind of general ideas. And then algebra is when you start doing the deductive reasoning. And then what I call, this is my own term, constructive algebra. I like making up my own words. It's fun. And that is, it's more of a creative exploration using logic. Okay? And that's kind of the stages of math. And so they actually somewhat correspond.
Where's calculus?
Calculus would be a constructive algebra.
Okay.
So
I don't think Newton would be happy with you.
I think he would. So the the abstract logic increases as you go through this, and these are largely correspond to developmental stages. And then in the classical, they somewhat map to the classical model. The first two.
So number sense is like
is the
grammar
stage, but also a little bit of they kind of overlap slightly. Number sense plus a little bit of arithmetic is grammar stage, and then some arithmetic.
I would say that number sense and arithmetic would be like that is learning the vocabulary math and gaining some skill with manipulating the numbers, and then algebra would be where you start asking questions like
and solving things
and solving equations, and
then constructive algebra is the rhetoric stage. So
But we say the theoretic stage is when you can teach somebody else what you learned.
So number sense.
Number sense is what we do so naturally with babies and preschoolers and toddlers because we're interacting with them and they aren't talking back, so it's not a real conversation. Like, oh look, we can stack these. See how we stack these cups? See how we put these in order? Oh look, there's 5 of them and there's 5 people, and so everybody gets one. And we say that all the time to babies and toddlers. It's just as you're talking with your kids, they're just the things that come out because it's what you're doing. And you can't lecture them on, the great benefits of whatever is what any good. So you talk about the physical things that are in front of you.
And you also just increase more intentional about using numbers with things.
Yeah.
And saying things like, oh, everybody needs 2 forks. There's 4 people. How many forks are we going to wind up having? And they will probably have to count it out, but that kind of sets the stage for later multiplication.
Yep, that's all math.
So
this is a square.
Mm-hmm.
That is a rectangle. Would you prefer your sandwich in rectangles, squares, or triangles today? Yeah, I'm too mean of mom. Here's your sandwich.
No, I just go, I have a whole sandwich and I cut it in half. And I have 2 halves that make a whole.
Exactly.
And look, if I cut it this way,
I
then
have
there's 4. But it's all one whole sandwich. Likewise, pizza. And then as they get older, there's figuring out who gets how many of whatever it is in order for everyone to have had their fair share, because I live in a house of men. So if there is bacon, it must be counted.
That's right. We have the same problem with my girls.
You must count the bacon and know how many pieces of bacon everyone gets, and woe to she who divides it unevenly.
Yeah.
But that's all the concept of fractions, the concept of multiples, and of division. Like, we have 14. Oh, look, there's 5 of us. Whatever shall we do?
A remainder.
We have a remainder of 4 pieces of bacon. And how many pieces do we have to cut it into to divide it among the 5 of us? So, oh my. So, and this is what we just talked about. It's really easy with a preschooler or a toddler. Can you bring me 2 of whatever? I'm trying. In my season, it was, can you bring me a diaper and 2 wipes? Because I can't get up and this is not working and I have to finish changing the baby. Would you please, a diaper and 2 wipes? So it's so easy but in doing that, he's gone, so he paid attention, he obeyed, he came back with 1 diaper and 2 wipes, so he got the diaper, he counted the wipes. That's like total win for a 4-year-old. And he helped his mom, he helped his brother, and he did a job well. So there's so much to be gained from that simple interaction that we don't even really think about as being a thing. Yeah. And this is totally just thinking about what you're doing and applying, wow, and in that, we've done all these things. So how many people do you set places for? What shape is that?
The calendar thing is really interesting because calendars give you a number line. So before you ever see a number line, you see a calendar. So you can say, well, so today is the 22nd, what's 3 days from now? And they can go on the calendar and it operates just like a number line, but it's much more concrete and deals with everyday things.
Yeah.
So you also can do, today is Wednesday, 2 days ago, what day was it? And hopefully with practice, they come up with Monday, which is another calendar skill for forward and back. Telling time. I have a friend who was homeschooled. She learned to read an analog clock after her wedding when her husband taught her because she had never been taught. So, yes, reading all kinds of clocks is important.
And knowing what fraction really mean, I don't know how
Yeah.
many people I before I understood a quarter of something was not 25.
Yeah,
I
because a
related it
quarter
to
of a
money.
dollar is 25, but a quarter of a cup is
Or but a quarter of the time in an hour
quarter of the time is
was not
15
25
minutes.
minutes.
No,
I always thought that.
because
right.
the hour is 60 and
Yeah.
so it's all just really number sense. That's all it is.
Yeah.
The multiple bacon here. We've already covered bacon, fractions, and pizza, so we're
Yeah.
good.
And recipes are the other big thing.
Yeah.
So
And the thing that if you cook a lot and you use recipes that aren't American,
That's challenging.
really useful to know how many ounces are in a cup, and that a quarter of a cup is 4 ounces, and no, that's not right. A quarter of a cup is 2 ounces.
I have to Google that.
And how many?
There's
8 ounces.
I don't know. I have to Google
There's
that.
8 ounces in a cup. 2 tablespoons
Yeah.
is about an ounce. 30 milliliters is about an ounce. Yeah. So like all that random. If you need to do a recipe that's not American, you have to use all of that. If you're drawing up medication, they always give it to you in milliliters, and then if you don't have the right thing to measure with at home, it's a problem.
So arithmetic, when you're doing number sense, the numbers are mostly intuitional. You're not hard hammering home any direct logical thing. You're just trying to feed their intuition. And later in algebra, you're kind of back to the same thing. You're trying to get people to be able to use their imaginations as much as they are using their pen and paper. But in the middle, you've got arithmetic, and that's boot camp. That's where you teach them to march in line and do the things that they're supposed to do and get really good at it.
Sometimes it's a handwriting problem, arithmetic.
Yeah.
Because doing long division requires you to line everything up correctly. Graph paper or turning the notebook paper sideways. That works too. Also for long multiplication, which I know really isn't what you call that, but you know what I mean.
Yes.
But also the handwriting problems are real in our house.
Yep.
There's a reason John won't write on the board. So I wind up scribing some, and he's like, put a 5 there. But if we've done the problem 3 times and it was wrong 3 times because it wasn't lined up correctly, it's time to do it right. And he's getting better. He's 10. He doesn't write. Yep.
So the other thing about this stage is memorization, because it's really important to memorize your facts. And the reason for that is that, yes, it's really important to memorize your facts. And the reason for that is because later on, you will be so glad you memorized them. Because when you get into algebra is not hard. What's hard is doing algebra if you haven't memorized your facts. And all of the things that if you memorized it and you can immediately divide in your head, then a lot of things just come easier. It's when you if you have to labor through both the algebra and the math facts, then the whole thing feels impossible. But it doesn't feel impossible if algebra is the only part of it you're doing.
A lot of times the students we see have a lot of problems with algebra. They don't have a problem with algebra. They have a problem with arithmetic. Because once you start to, if you see the number 64, you should automatically kind of think about what are factors of 64 and how does, like, 64 is 8 cubed. No, it's 4 cubed.
Yes.
4 cubed, 8 squared. But that should be pretty automatic. that 8 times 8 is 64.
So, yeah, basically you need immediate knowledge of each basic math fact, and that is something that's critical for all later stage development. But what Krista likes to do is she likes to invent math games. So
Their favorite is the 2 dice, though. We have 2 12-sided dice, and so like they'll roll it and say the answer. Roll both of them and say the answer for multiplying them together, and 5 minutes maybe. Or I'll play with them and we'll see who's faster. Or they'll play together and see who's faster. But once you've kind of introduced all the multiplication facts individually, then for practice, you're just looking for speed and ease.
So
Skip counting songs are pretty great too, just for
especially when you get stuck. It's good for starting to learn, but also every once in a while you get stuck, and that way you at least get the right answer, even if you don't have it memorized.
my algebra class sang the cube song a lot. There's a cube song.
Are you in CC? Okay.
Well, the cube song. 1 8 27 64 125.
Krista
Now
forgot
I
our
got
cubes.
stuck. 216, 343, 512, 789, 1,000. But then when you're doing algebra and 343 is in your problem with the cube, you don't have to panic because it's 7 cubed. So it's just totally familiarity with the cubes.
Yeah, and CC has songs for skip counting every.
Yeah, so does Mr. Demi and Matthew C.
Yeah, and skip counting squares and cubes. So you kind of get familiar with the basic ones.
Yeah.
So, but you also, doing mental math is good, but you also should write it down, and that's just kind of we've learned our kids have some of our kids have handwriting problems.
All of our kids have handwriting problems. I did not create them. The handwriting problems. I know this. He did.
So
it's genetic.
That's
what I came to. We're working on handwriting so that it's legible and you can do your math and have it all line up correctly. But like the 11-year-old prefers doing math in his head and only writing down the answer.
Yeah.
It doesn't work for us.
Also, part of the problem is if you have to write big, then
it doesn't.
Then it doesn't fit, because eventually you're going to get to problems that are harder. And,
yeah.
And that's actually I think that's somewhat daunting for kids. I mean, even if it's the same problem that they would have written in a small space, if it takes up the whole page, it just feels overwhelming.
Yeah.
So then for kind of advanced arithmetic, money is probably the best leader for that, because you've got decimals. You can talk about. What I've tried to do is I've tried to do little micro businesses with my kids, and so we talk about how much does it cost to put this together, how much are we going to sell it for, so how much are we going to profit, and so if we're going to recover our cost of materials, how much do we need to, how many units do we have to sell? And so just doing stuff like that, it's all arithmetic, but it's all decimal arithmetic.
And it's purposeful.
Yeah. So you can do science observations, decimal points on that, and then also building. This is something that I
Adding
can't.
fractions. It happens in building.
Yeah. All those 3/16 of an inch. This is not something that I have personal knowledge of, because that construction is way too real for me. I'm a theoretical guy. So when you get into actually constructing things, I did in fact build a chicken coop once.
My husband is in the middle of doing that right now.
Yeah.
And he's such a perfectionist that it's almost like, okay, just let it go.
I'm not a
It doesn't have
perfectionist.
to be
Yeah.
perfect.
Okay, so we had the opposite problem because he's not a perfectionist and it was ugly. And so I was like, why couldn't we have worked together? Because then it would be pretty. It's like, it's a chicken coop.
My husband's actually put one of those things that you have on the front, like a trailer, that you roll down to put the wheel, I can't know, whatever they're
Mhm.
called, so that you can turn it and move it around. And I'm like,
Oh, so it's a
anybody's
tractor.
ever put that on a chicken
It's a
coop.
chicken tractor.
Yeah.
That's awesome.
That is cool. Yeah, so just being able to follow instructions and that kind of stuff. Some of the ways you can do some more decimal math. And then one of the things when you're doing complicated stuff is just to remember, because that the most important thing is process, because process is what gives you the answer. Not skipping steps, because that's one thing that kids always want to do. They want to skip steps. And so sometimes skipping steps will give you the right answer, but they need to do the process the right way. The other thing is that the process also helps you know why, because the process is oriented around the nature of the numbers. And so if you do the process right, it at least helps you get to the point where you understand why you're doing it that way. It's not just some weird witch's brew formula. It's actually, it's inherent in the way numbers work. And making sure they write down every step every time. And then the small mistakes add up. So try to catch those early and fix them. So then my favorite part is algebra and constructive algebra. And I actually
This is where that doing every step thing really matters, because if you skip steps in algebra, you will not have the right answer.
and you won't know why.
Yeah.
And the constructive parts of algebra are actually my favorite.
But
So
you don't like constructive geometry at all.
So the main thing on algebra, the number one thing is defining your problem well. And so that's understanding the meaning. I always say the step one of math is philosophy. You have to understand what the problem means before you can actually attack the problem. And if you understand what the problem means, then that actually oftentimes will tell you how to attack the problem. Then you need to be specific about your knowledge. What are the knowns? What are the relationships? And then be specific about your ignorance. And that's what variables are. Variables are just being very specific about where you're ignorant. That you're finding X. Why? Because you don't know. So, and then as I said, algebra problems are about converting questions into answers using the interior logic of the questions. And then the third one, if you're doing constructive algebra, you can convert the sequence of steps that you just did into a formula for later use, right? Because that's one of the things. A lot of times in early math, they give you formulas, the area of a circle, all these fun little formulas, and you just take them because that's what people gave you. Later on, in more constructive areas of math, you actually can put these together and show how to get those, where they come from, because they didn't fall out of the sky. Someone figured them out, and most of them, and this is actually why I love calculus, because calculus is where most of these come out. As soon as you learn a little bit of calculus, then all of these formulas that you thought were handed down on Mount Sinai all of a sudden just make a whole lot of obvious sense. You're like, oh, yeah. And so you do constructive algebra even before that, but calculus is my favorite because there's just so many things that are just intuitively obvious once you know just a little bit of calculus. So about understanding the meaning of the problem. So it's about thinking about how the process relates to the problem. And if you try to answer the question first, then if you just try to answer the question right away, then you skip that whole mental process that you're supposed to go through. And the nice thing about this, when you master this skill, then it helps you with every other thing in life, because you learn how to convert. Because people talk in very vague generalities, and this helps you to narrow those down into concrete questions. And that's like, if you read any good business book, any good science book, all of them, all the good ones, focus on converting these generic questions to very concrete questions. And once they're concrete, solving them becomes a lot easier. So that conversion process is one of the most important parts of math, I think.
Well, and that's like another hark back to the grammar stage comment you made earlier, because you're defining what numbers are what and what they mean.
Yeah.
So before you start thinking about the relationships between them.
So when you convert it to mathematical language is precise, and that allows you to work with it a lot better. So then, you be specific about your knowledge. So that's, what are the numbers that were given? How do those numbers interact with each other? If someone gives you a speed, what does a speed mean? Well, speed means the distance covered per unit of time. And just writing that out and understanding
miles
that.
Per hour,
Yes, miles per hour.
kilometers per hour.
And just thinking about the meanings of those things. And then you figure out what relationships they're talking about in the problem. Is this a triangle? Okay, well, what do we know about triangles? Okay, well, what are there relationships among triangles that we know? Well, we know all the angles add up to 180 degrees. If it's a right triangle, then we know certain relationships about the hypotenuse and the sides and that sort of thing. And so you just go through and you figure out, what are all the things that we know about this? And what are the formulas that we know that relate both to our knowledge and to the end goal? And then finally, we're specific about our ignorance. Say, well, what quantities are unknown? And make sure that every unknown quantity gets a variable. And you can give them x, y, z, or if they're similar, you can say it's x1, x2, x3, however you want to roll with that. The main thing, I would prefer too many variables rather than too few. Because it's real easy to substitute things in. It's hard if you skip a step. And then try to identify any missing relationships that you think might be available but you don't remember or don't know. So, I remember something about the way that these things relate, but I don't remember what it is. That'll at least help you know where you need to go. So then we convert questions into answers. So the rules of arithmetic allow us to manipulate the equation. And they allow us to convert the question into something more manageable, use the rules of substitution to convert each piece of knowledge to something new. And so you can just use the internal logic of the problem to keep on eliminating unknown quantities until you come to a final definition that you can solve simply. And then always remember that to have a chance at completely solving a problem, the number of equations must at least be equal to the number of unknowns. And then for constructive algebra, the goal is to convert the solution into a repeatable formula. Okay, and so this is used a lot of times in computer programming. You first use algebra to figure out what it is you're trying to do, and then you convert that into a formula that you can just plug into the computer. And so basically the goal is, so the main thing is to understand which parameters are important. What are the things that are going to change problem to problem? And basically you create stand-ins for those. So you create kind of what I call them constant variables. They're constants for a given problem, but They vary problem to problem. And so, so as an example, just for algebra, so if someone says find 3 consecutive odd numbers
Right on the board.
that add up to 111. Okay. So 3 consecutive odd numbers that add up to 111.
We have 3 numbers.
Yes. And so the first thing is, what does the problem mean? All right. So if you have 3 consecutive odd numbers that add up to 11, you first say, well, they tell me it's an odd number. What is an odd number? So, well, odd numbers are not divisible by 2, and they occur every other number. Okay. So those are important facts. Now we might not use all the facts, but they're definitely important for us. So what do we know about consecutive odd numbers? Well, each odd number is just 2 after the last odd number, right? So then we can then precisely write out what our knowledge and our ignorance is. Okay, so we've got three numbers that add up to 111. Okay, and so A is our first one. B, because it's a consecutive odd number, is just whatever A was plus 2. And C is whatever B was plus 2. So that's our knowledge and our ignorance. We don't know what A, B, and C are, but we know these relationships between them.
They add up to 111.
So anyway, we basically have 3 equations, and then we say, what can we eliminate? And so basically what you do is you just substitute. I mean, this is now just a problem of substitution. So we start out with A plus B plus C. Now we substitute, since C is B plus 2, we have A plus B plus B plus 2. Okay? And now, because we know what B is just A plus 2, so now every place we had B, we can substitute A plus 2 because they're equal. And then, using basic rules of arithmetic, you can just regroup those. And you can group all the numbers together, and you can group all the letters together. So,
Like this. Does that make you happy?
yep. So now you can further use the rules.
So I have 3 A's, so I can say 3 times A plus 2 plus 2 plus 2 is 6 equals 111.
Right? And so now,
Now we
Since
have
they're
to
both-
unadd.
yeah, since they're both equal, I can do, as long as I do the same thing to both sides, I can do anything I want. So,
Yeah.
It's been a while.
so
We're not gonna
3A,
divide by 3.
so we divide by 3.
Okay, so now I divide both sides by 3. I get A equals 30.
35.
35. Oh yeah, you're right.
So there. So as you can see, we started with what we knew and what we didn't know, and we just converted that to the final answer. So we took our question, and yeah. So now that we knew that A is 35, B is A plus 2, so B is 37.
I got too close to myself there.
And so we just used. Let me write one more. Plus B plus C. So you can see that we just start by substituting one, and substitute the next one, and then regrouped, and then did some simple manipulations, and then converted to our answer. So basically, it's that you think about what is the problem, what are the features of the problem, and if you can get your question down to a rigorous enough, concrete enough question, then you can literally convert the question into an answer. And so that's the core idea behind algebra, is doing it that way. So then for constructive algebra, it's very similar. Okay, and so let's just say, so you have Jim and Bill, and they leave a point going in opposite directions.
Okay, so here's a point.
And also, drawing out algebra problems is always helpful.
There you go.
So they're going in opposite directions. Jim is traveling at 10 miles per hour. And Bill is traveling at 15 miles an hour. So how far apart will they be after 3 hours?
They drove a long way to go to a movie together.
Yes. So what does the problem mean? So Jim and Bill leave a point. Okay, so that means their starting distance apart is 0, since they're both at the same point. Jim and Bill are going in opposite directions. So since they're going in opposite directions, the total distance between them is just the addition of the two distances. If they were not going directly apart, you'd have to do funny trigonometry. But since they're going in opposite directions, the total distance is just adding them up. So then you say they're traveling at different fixed speeds. Well, what is speed? Speed is the distance for a given time period. Okay, so we need to precisely express our knowledge and our ignorance. Okay, so the primary thing is we don't know how far apart they will be. So we'll call this x. Okay, so x is how far apart they'll be. So we know x consists of how far Jim went and how far Bill went. Okay, so Jim's distance we'll call dj, and Bill's distance we'll call db. Okay, so we know their starting distance is 0, so the only thing that x involves is dj and db. So we can simply say x equals dj plus db. Because that's exactly what we know about it. We don't know anything. We don't know what dj and db are, but we do know that our final value is going to be those two things added together. Because that's what it means if they're traveling apart from a point. So we know their starting speeds. We know their speeds. That they're just going 10 miles per hour and 15 miles per hour.
Yep.
So we also know how long they've been going that way. So the distance traveled is your speed multiplied by your time. So you can actually see that in the units in here, because this is distance over hours. So if I multiply by hours, I have distance left. Right? So I've gone for 3 hours. So each of these, I might multiply each of their speeds by 3, and I get how much each of them went. And since I know x is dj plus db, then I can just throw those in. Okay, and finally, x equals. All right, so after 3 hours, they're 75 miles away. So, but let's say, so if we want, now we want to convert this solution to a formula that we can use over and over again. Okay, and so what are our numbers? We have the speed that each car is traveling, and we have the number of hours. Okay, so what we're going to do is rather than use numbers, we're going to create stand-in variables for those guys. So h will be the number of hours. Okay, and h is true for both of them because we're doing the same amount of time for both of them. So h is the number of hours, and the speed of Jim's car we'll call sj, and the speed of Bill's car we'll call sb. Okay, so now we've got formulas for dj and db. And so now we can use this formula to combine them. Okay. So x used to equal dj plus db, we already have that.
Okay.
So x equals, and so your first one, so you used to have dj.
So now I have SJ times H.
Yep.
Plus SB times H.
Okay, and so once you have that, I mean, that's good enough, but you can actually go even further, and you can factor out the h. And so you can have x equals h times sj plus sb. And so now we've taken are steps that we use to solve the original equation, and just by throwing in stand-ins for them, we converted it to a formula. And so now we've literally created our own equation. So this is the Bartlett equation.
So now if we wanted to say,
We want to say they were going 5 and 7 miles per hour for 4 hours, then you just do it like that. So, anyways, I call this constructive algebra. I think this is really what
Where you want to get.
yeah, and this really makes it a home run.
Yeah.
Because this is what you will use forever and make you always appreciate algebra. You can take problems, and not only can you find the solutions, you can make it so you don't have to find the solutions in the future. You can just plug it in. And so I can give this to a computer programmer, and he can implement it. I can give it to the checkout clerk, or whatever.
And they'll cry.
Yeah.
Let's not do that. No
Sure.
crying cashiers.
I can give it to whoever I need to, and they can use it to find it. So, and that's what. So once you learn to do this, you can write books, because then you can figure out your own things. You calculate what the formula is, and you can write a book and sell 1 million copies of how you solve some of these problems for forever. So, anyway, a few tips. One of the biggest problems is trying to solve the problem immediately. My oldest son tries this all the time, and every time he just tries to go straight from the question to the answer. You're like, no, that isn't right.
it does not ever work.
And so if you don't know where to go, listing out every relationship you know about the things involved will help. And then the other thing is taking an incremental approach. What's the next thing that you know, right? Because that's how we solve. Once you learn to solve things, you're like, okay, well, even if I don't know how to do the whole thing, what's the next thing I can do? And once you start getting in the habit of doing just the next thing, that helps you in everything. Like if I don't know how to put on an expo, you just say, well, what's the next thing that I need to do? And that will help you throughout your entire life. So skipping steps leads to
You
mistakes.
don't know how to make macaroni and cheese.
Yep. What's the next step?
Here's the macaroni. I should read the instructions.
And so the one thing that's interesting is that when you try to go too fast, it oftentimes shows that you haven't bothered to understand the problem first, which is the most important thing. Because the primary thing is not about solving the problems, but about thinking deeply about the logical relationships between the pieces. And then sometimes we all forget things, and if you forget something, then sometimes finding a small instance of it will help you remember how it works.
Sometimes if your numbers that you're thinking about are big, pretending the numbers are smaller, make the system make sense.
Yeah.
Then you can put your big numbers back in. But
So, and I always like to put in a plug for calculus because it's my favorite.
The professional engineering exam, and he was studying, and the math books he was looking at, it looked like a foreign language.
There is the concepts of calculus, and then there's all the things they want you to do in calculus. And the sad thing is that the concepts are actually really simple. But everybody combines the concepts with all the crazy things they want to do with it. And so, unfortunately, that means that calculus textbooks wind up looking like they're written in a foreign language because they always try to do the hardest things that they can think of. And you could do a large section of calculus right after Algebra 1, honestly. But few people arrange it that way. No one writes books for that. So,
There you go.
Except
There's
for
a
Fred.
well, I'm actually working on one kind of like that.
That's a good goal right there.
Yeah. And so, anyway, it focuses on the constructive side of of algebra and constructing equations from other equations using basic principles. And as I said, pretty much anything that you're just given as mystery magic in physics, geometry, all those things, you can do from basic principles of calculus. if you've ever worked with physics and you have the position equation for if you drop a ball off a building, that equation, no one who knows calculus has to memorize it because it's just it comes straight from the most basic calculus principles. And then the other thing is that calculus is the entry point to science.
Actually taught, I'm a nurse, but I got my teaching degree, not my teaching degree. I went and took the test to teach biological sciences.
Mhm.
And I had a job in a Christian school, so they let me teach math too.
Because
What
that's how
school?
that goes there.
What
Legacy
school?
Christian School in Claremore.
Oh, cool.
And I taught for 2 years, and then I had her and then stayed home. And I was a school nurse here for that, and that's when I knew I was never sending my children home from school. Being a school nurse. And a
Okay,
homeschool.
so I decided we were going homeschool when I quit my education degree because besides like the fact that I hate cutting out things for bullet points, I could not like this cannot possibly be the best way to educate anybody. Stick them all in the same room and
Just the things going on behind the scenes that I saw as a nurse was like terrifying.
yeah.
I was like, I can't believe y'all are doing this.
Like what?
They were having meetings with the high school students about planning doctor's appointments and different things without parental consent.
Oh, that's
I was in there with my jaw like on the floor going, is this even legal? Like they were telling me it's illegal for me to notify parents, and I'm like, I don't understand.
Yeah.
And then there was just all kinds of things in elementary that I was just, wow, this is crazy. And it was just
Yeah.
seemed like mass chaos to me. That the principal at one school was just like she was running nonstop. It just felt chaos and chaos, and there was just so many things. And the things kids were coming in with, and I'm like, I don't think I was that naive in high school, but maybe there was more of this going on than I knew of. But if not, it's way worse now. If I knew what was going on in my high school, then it's way worse today.
Yeah.